Every time you do a search, stream a show, or ask an AI a question, there's this invisible cost. And it's not just about electricity. It's a huge, unseen environmental price tag, one that's absolutely exploding with this whole AI boom. So let's dive into this hidden world and really uncover the true cost of a click.
Okay, to get our heads around this, let's just start with a super simple question. When you ask a chatbot something, how much water does it actually drink? I mean, you'd think the answer is like 0, right? But the reality, well, it's way more complex and honestly kind of shocking.
And this is where things get really wild. On one side, you have a top AI saying a single query uses just a tiny fraction of a teaspoon of water, practically nothing. But then, on the other side, you've got analysts from Morgan Stanley predicting that by 2028, AI's annual water use could hit 1 trillion liters. That's an 11-fold increase from where we are today. So, how can both of these things possibly be true? What are we missing here?
Well, to solve that puzzle, we've got to understand why our digital world has this very real physical thirst. And it all boils down to one simple, unavoidable fact of physics. 500 milliliters. So, get this, according to researchers, that's how much water it can take to cool the servers for just 10 to 20 simple questions you might ask a model like ChatGPT. We're talking about the amount in a standard bottle of water. And no, this isn't water inside the computer, it's water used to cool the massive data centers that power the AI. But why on earth do they need so much?
It really is all about heat. AI workloads push those graphics processing units, the GPUs, to their absolute limit, and that makes them intensely hot. I mean, we're talking crazy hot. And that extreme heat doesn't just slow them down, it actually shortens their lifespan. So to keep these billion-dollar investments running cool, data centers turn to one of the most effective methods we have, evaporating truly massive amounts of fresh water to carry all that heat away.
But that incredible thirst for water, that's really just the beginning of the story. It gets a whole lot darker when you start looking at the secrecy, the pollution, and the very real human cost of this digital gold rush.
You see, a huge part of the problem is we just don't know the true scale of it. Tech companies often work really hard to hide just how big their data center footprint is. It's like they're building a secret geography of consumption that makes it almost impossible for anyone to hold them accountable.
Now check this out. This is what I mean by pulling back the curtain. Take Mumbai, for example. On his website, Amazon says it has just 3 availability zones there. But leaked internal documents from 2023 told a very different story. 16 data centers. That is more than 5 times what they were telling the public. And that hidden infrastructure, it has a massive real-world impact. This created a surge in local energy demand so high that aging, polluting coal plants that were scheduled to be shut down were kept running. And to guard against blackouts, these facilities also have to rely on dozens of diesel generators, which just makes air pollution worse and adds to a public health crisis in a city that's already struggling to breathe.
But it's not just about energy. As companies move to even more advanced cooling methods to handle the next generation of AI chips, a new and pretty terrifying toxic threat is starting to emerge. I want you to meet PFAS. You might have heard of them as forever chemicals. These are synthetic chemicals used in these new high-performance liquid cooling systems. And yeah, they're incredibly effective, but they have a terrifying downside. They just don't break down. Not in the environment, not anywhere. They build up in our water, our soil, and in our bodies, and they're linked to a devastating list of health problems. We're talking cancer, birth defects, the works.
So the crucial question is, who's bearing this risk, right? These massive industrial facilities, they're rarely built in the backyards of the executives profiting from them. Nope. They get put in rural areas or on indigenous territories, like that of the Sturgeon Lake Cree Nation in Alberta, often without any real consultation. Or they're built near historically black communities, like Elon Musk's XAI facility in Memphis, which actually prompted the NAACP to sue for environmental racism.
So when you're faced with these very real earthly limits, finite water, dirty energy, toxic chemicals, some of the biggest names in tech are now proposing a pretty radical pivot. They're literally looking to the stars for an answer.
The whole idea sounds like something straight out of science fiction. Just take the data centers with all their heat and energy demands and put them in orbit. Launch these massive satellites that can be powered by the sun, and this is the key part, cooled by the endless, freezing vacuum of space. This table just lays out the logic perfectly. Here on Earth, you're stuck using fans, which are pretty inefficient, or liquids like water and those PFAS chemicals, which have huge environmental costs. But in orbit, you just use radiative dissipation. You literally beam the waste heat directly into the void. Power comes from constant, unfiltered solar energy, not some fossil fuel grid. And the direct water use? It drops to 0.
And the energy advantage is just staggering. A solar panel down here on Earth is dealing with the atmosphere, clouds, and, nighttime. That same panel in a sun-synchronous orbit can generate between 8 and 13 times more power. It's a fundamental game changer for the entire economics of computing.
And let's be absolutely clear about this. This is not some distant dream. The race to build this orbital infrastructure is happening right now. It's sparking a new geopolitical and commercial sprint to what a lot of people are seeing as computing's final frontier.
I mean, just look at this timeline. It shows you just how quickly this is all unfolding. In late 2025, a startup called StarCloud became the first to successfully train a large language model in orbit. Just a few months later, in early 2026, Axiom Space launched the first dedicated orbital data center nodes. And later this year, a European mission is going to test robotic assembly in space, a key technology for building these massive structures. This is moving incredibly fast.
But, of course, solving one set of problems often creates another. All these rocket launches release black carbon into the upper atmosphere. And when thousands of these satellites eventually burn up on re-entry, they'll deposit metallic particles that could actually damage the ozone layer. And every single launch increases the risk of space debris and collisions, which could trigger a chain reaction that makes orbit basically unusable for everyone.
And all of this brings us to the final and maybe the most important piece of this whole puzzle. As we're standing on the edge of this new frontier, we need more than just a new technology. We really need a new philosophy.
There's an Indigenous-led initiative called the Star Nations Strategy that offers exactly that. It completely reframes this entire conversation. It argues that the tech industry's current path, taking finite resources like water and land just to fuel computation, is really just a new form of colonial extraction.
And their core principles are, well, they're profound. First, data is kin, not oil. It should be treated like a sacred trust, not a commodity to be mined. Second, Indigenous communities must have sovereignty and control over their own data and the infrastructure that supports it. And third, we have to protect Earth's most vital resources by moving technology's insatiable thirst to space and reserving our planet's water for life itself.
And that leads to this incredibly powerful, crystallizing idea. A quote that just perfectly sums up the choice we're facing. As we build the future of intelligence, are we going to continue to drain the resources of our only home? Or will we find a new path? One guided by a simple, undeniable truth. AI is for space because water is for life. What path are we going to choose?